Good evening, everyone. This is January 2015 of Unit 5 IAL Physics. Question 1. A source of alpha radiation is dangerous if taken into the body. This is because the alpha particle, so what is alpha particle? Because of their greater mass and charge, they are very ionizing. That's why C is the right answer. A student carries out an experiment to measure the specific heat capacity of aluminum by heating with electrical heater. Specific heat is equals to energy divided by mass and change in temperature. The value obtained by student is less than. So if the value is less, it means what could be the likely reason? Heater was inefficient. So if heater was inefficient, because energy is power multiplied by time, so heater will be used for a longer period of a time. If it was inefficient, if the time increase, the specific heat capacity should increase. The mass of a block is overestimated. That's right, because if mass is overestimated, if a student use higher value of a mass, he will get a smaller value of specific heat capacity. The thermometer scale did not start from zero, does not have any effect on the reading, and thermal energy transferred. So thermal energy is transferred to the surrounding. So the heater will use for a longer period of a time to cause a change, make a change in temperature. So it will also increase the value for specific heat capacity because this high Q will be higher. But in the question, student is getting a smaller value. This means he overestimated the mass of the block. A pan contains water at 300 Kelvin. The temperature of a water is increased to 330. Assume that the pan behave like a black body. So rate, the power or luminosity is equals to surface area 4 pi r square into t raised to power 4. So means we can also say luminosity is proportional to temperature raised to power 4. Or L1 over T raised to power 4 is equals to, or you can also say L is proportional to, here's Stephen Boltzmann law is there, so sigma is also there. So we can write, because the same object and this all constant, so we can simply say like L is equals to constant T raised to power 4, or L1 over T raised to power 4, T1 raised to power 4 is equals to constant. Because here temperature changes, so L1 over L2 is equals to T1 raised to power 4 divided by T2 raised to power 4. But we need L2 over L1 because the factor changes, so it is L2 by L1 is equals to T raised to power 4, T2 raised to power 4 divided by T1 raised to power 4. So T2, it's 330 raised to power 4 and 300 raised to power 4. So when we substitute, it will come out as 1.5. Question 4. The scientists believe that significant proportion of the universe consists of a dark matter. The dark matter is not an antimatter. It's not a black dwarf. It's not undetectable. It is invisible. We are not able to see. So D is the right answer for this. Uranium-238 decay by emitting alpha particle. It is not possible to influence the decay. So because the radioactivity is a spontaneous process, that's why it cannot be influenced by external conditions such as pressure, temperature, change in state. Scientists believe that the universe is expanding and there is a critical density. So critical density is the density of a universe calculated by using Hubble's constant, and the average density is what matter we see, observe. Using that we work out average density. So if the average density is higher than the critical density, then universe will be a closed universe. And if average density is equals to the critical density, then it will be a flat universe. And if average density is less than the critical density, then we have or open universe. So the option which matches closed and flat, so 6A is the right answer. Question 7. The diagram shows a line spectrum produced by a source in the lab by a light from distant galaxy. A correct deduction. So what we can see, they have the same lines, but what it shows that the wavelength increase. So if wavelength is increasing, it means according to Doppler effect, the source is moving away. So the galaxy is actually moving away from the Earth. That's why C is the right answer, as the wavelength is shifted to the longer side. According to lab, what we are getting and but what we receive from galaxy is a longer wavelength. It shows that the galaxy is moving away from the Earth. All objects at a temperature above absolute radiate energy. The wavelength and at which the peak energy emission occur and the rate of energy emitted per unit surface area depends on the temperature. So if the temperature is increased, so we have lambda into T is equals to 2.89 into 10 to the power minus 3. So it means that wavelength and temperature are inversely proportional. If temperature is increased, the wavelength should decrease. And the power or the luminosity is proportional to fourth power of temperature. If the temperature is increased, the luminosity will also increase. So lambda max will decrease where the luminosity will increase. Question 9 and 10 refers to the graph. Which graph shows how the kinetic energy of a mass undergo a simple harmonic motion vary with distance x. So it is maximum when the object is at the mean position, it is maximum and it decreases, but not a linear change. So which case it is decreasing, either B or D, but it's not a linear change, it's a non-linear change. That's why B is the answer, which is a graph for kinetic energy, because at the mean position the object will have a maximum speed or higher kinetic energy, and extreme position it will have a smaller speed, lower kinetic energy. Question 10. Which graph shows how the magnitude of resultant force on a mass undergo a simple harmonic motion vary with distance? So force and acceleration are directly proportional, and we know for a simple harmonic motion acceleration is directly proportional to displacement. When two quantities are directly proportional, there should be a straight line. So same way we can say force is directly proportional to displacement as well. So which graph shows a direct proportion relation? A. That's why for question 10, A is the right answer. So this was January 2015, Unit 5 of IA, Unit 5 of IAL Physics.